Guys had to finish up these two problems, and so I'm going to go over them so you guys can check your work and see how well you did. Because you're supposed to do this roller coaster problem and then the Ferris wheel problem. So it says part of a roller coaster track is a sinusoidal function. The high and low points are separated by 150 feet horizontally and 82 feet vertically as shown. The low point is 6 feet above the ground. It says write a sinusoidal model that sinusoidal function that models the distance the roller coaster track is above the ground at a given horizontal distance x. Now, hopefully, you realize that if the roller coaster is 6 feet off the ground and then it's 82 feet between the top of the roller coaster and the bottom of the roller coaster, then the height of the roller coaster is actually 88 feet versus 82 feet because you have that additional 82 feet here plus 6, which makes for a total of 88. So the maximum should have been at 88, and then your minimum should have been at 6. Okay, hopefully you recognize that. And hopefully you also recognize that it was 150 feet to go from max to min. And going from max to min is only half of your period, so if you multiply it by 2, you get your actual full period, which should have been 300 feet. Okay? Since we are starting at a max, then we don't have any type of phase shift, but then we can actually figure out our vertical shift and our amplitude by using our two formulas. So to write our sinusoidal function to find our A, we're going to do max minus min divided by 2, and then to find our vertical shift, we should have done max plus min divided by 2. Okay? And then we should have also taken the 300 and set it equal to 2 pi over b to actually find the value of b that also goes into our equation. Okay? So if we solve these few things, this right here would have been 82 divided by 2, which is 41. This one here should have been 94 divided by 2, which would have been 47. And this one here should have been 300b equals 2 pi. So b should have been pi over 150. So your equation that you should have gotten should have been y equals 41 cosine pi over 150x plus 47. Okay? That should have been your equation. Now, to actually find part B that says point A is 40 feet to the right of the y-axis, how far above the ground is the track? So basically, somewhere at 40 feet, you're at a certain height above the ground. So basically, you need to plug in 40 for x into your graphing calculator to get an answer. Make sure you're on radian mode when you do that. And you should have ended up with a height of about 74.4 feet. Okay? You should have ended up with that. All right? Now, I talked about this in class, but I didn't get a chance to actually do it, so I want to do it right now. If it asks you to write a sine function, if it asks you to write a sine function for this curve, it's actually very simple. The reason why is because your A, your B, and your D stay the same. The only thing that's different is your actual phase shift. So here we go. So all of this stays the same. But it's your phase shift that changes, okay? And if you recall from the notes before, on the very first page of your notes, it says the sine function has the same amplitude, vertical translation, and period, but its horizontal translation is 1/4 of the period to the left. So it's 1/4 of the period to the left of your cosine curve. So since we already created our cosine curve, we can create our sine curve basically just by doing this little bit of math and then subtracting it into our formula. So basically, we'll take 1/4 of our period. So our period is 400, so we're going to take 1/4 of that, and we'll get 75. 75 represents our phase shift. So then from there, we would set 75 equal to negative c over b to actually figure out what is c into our equation, okay? If we do a little bit of, keep going down, we're going to end up not even seeing the problem a little bit. If we do a little bit of keep, change, flip, that'll be a negative 150c divided by pi, multiply both sides by pi, and then divide by 150, negative 150, we'll get to be a okay? And I need to make sure I fix this real quick, because you take 1/4 the period to the left, which means that this will actually be a negative 75. So whenever you move to the left, that means it's going to actually be a negative. So then when you cross multiply and you divide, you'll actually end up with a positive here. So again, just to recap, when you write the sine function, the a, the b, and the d all stay the same. But what you're going to do is you're going to take 1/4 of your period, and you're going to move it to the left, which means that whatever you get when you take 1/4 of your period, you need to make it negative. That will give you your phase shift. Then you take your phase shift and set it equal to negative c over b. And when you solve, you end up actually getting the value that you'll plug into your equation. And what you can do is you can actually test this. Since you already know that point A at 40 feet above the ground is at a height of 74.4, if you plug in 40 into this equation, and actually, sorry, this actually should have been sine. I do apologize, it should have been sine. When you plug it into this equation, you should get 74.4 feet. So go ahead and test that out. Plug in 40 into this equation and see if you get 74.4. Pause the video and do that. Did you get 74.4? You should have. If you didn't, that means you probably didn't plug it in right. But basically, this goes to show that you created the right sine equation. Now for this Ferris wheel problem, it says that your distance from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts, your positions at the seat shown in the diagram. So there's your seat right there. It says let t be the number of seconds that have elapsed since the Ferris wheel started. You find that it takes you 12 seconds to make a revolution. A revolution is one time all the way around, so 12 seconds actually represents our period. Since it takes us 12 seconds to get all the way back to where we started. The diameter of the wheel is 55, and when you begin, your seat is 5 feet off the ground. So what's our period? Our period is 12 because it makes takes 12 seconds to make a full revolution. What's our amplitude? What's our phase shift, vertical shift, and then we're actually going to sketch this graph. Well, if we think about it, when we get up here to the very top, it's going to take half of the period. So first off, it's going to take us 6 seconds to reach the top, since it takes us 12 seconds to go around all the way at once. And then on top of that, we're at a height of 60 feet. Okay, we're at a height of 60 feet because the diameter wheel is 55 feet and we're 5 feet off the ground. This 5 feet would represent our minimum. So to find our amplitude, we're going to do max minus min divided by 2. So that's 55 divided by 2, which is, what, 27.5? To find our vertical shift, we're going to do 60 plus 5 divided by 2. So that's going to be 65 divided by 2, which is 32.5. We know our phase shift is going to be the time it takes for us to reach our maximum. And so since it takes us, we're going from the very bottom all the way to the top, that's half of your period, so that should have been 6. And now what we're going to do is we're going to graph this function, okay? So if you think about it, we started at 5 feet on the ground at 0 seconds. That's where we started off. And it takes us 12 seconds to get right back down to that point. Half the time, which is 6, will take us to our maximum, and our maximum occurs at 60 feet. So there you go. There's a nice little sketch. You don't need the equation to sketch this out. You just use the fact that you can use the problem to basically help you out. Okay? Now we can use all this information to figure out what's the lowest the Ferris wheel can go. Well, clearly the lowest the Ferris wheel can go is 5 feet because of what reason? Well, that's
Mr. Hill and Mrs. Hills.
The reason why it's 5 feet is because that's where the bottom of the wheel is. Okay, it's the bottom of the wheel. And you can say a couple of other things that would make logical sense why that's the lowest. Okay. Now, when we write the equation, we already know our A. We can figure that out to be 27.5. We're going to write a cosine function, because that would be easier. And then we know our vertical height is 32.5. pi over b. And when we solve that out, that'd be 12b equals 2 pi. So b equals pi over 6. So we'll plug that in. And since our phase shift is 6, we're going to set that equal to negative c over b. b is pi over 6. So with a little bit of algebra manipulation, we'll find out that our c is negative pi. So there is your particular equation for this curve right here. Got a lot of work going on. So now for question 4, it says predict your height above the ground when t equals 9. Well, t clearly is our, what I wrote as x, so I can change that up real quick. Make that a t. And we're going to plug t in and get that our height above the ground is 32.5 feet. All you do is plug in 9 for t, or x if you use x, and make sure your calculator is on radian mode.